Hello classroom, this is Sean Huang and we are teaching chapter 6.1.
Come back.
What?
Okay, bad camera work. Bad camera. Okay.
Okay. These are general and practical solutions.
Particular
solutions. So, here we have verifying solutions. We have a given equation, y double prime minus y equals 0. And we're given two solutions. We're going to verify these solutions and make sure that they in fact equal 0. So for A, y equals sine of x. Y prime is cosine of x, and y double prime is negative sine of x. So when we plug these two variables into our equation, we get negative sine x minus sine x, which is not equal to 0. Come down here to B, y equals 4e to the negative x, y prime equals negative 4e to the negative x, y double prime equals 4e to the negative x. So, 4e to the negative x minus 4e to the negative x equals 0. So this is a solution of this equation. These are general solutions. So down here, we have another equation, x, y prime minus 3y equals 0. And we have a solution, y equals cx cubed. So we're going to verify our general solution down here, x, y prime minus 3y equals x times 3cx squared, blah, 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 equals 0. That's true. So this is, in fact, a solution of this equation. But we have this little initial condition down here. So y equals 2, x equals negative 3. We use this to find a particular solution. So down here, we take our solution, which we verified is, in fact, our general solution, which is, in fact, for this. So we plug in our initial condition. So 2 is equal to c times negative 3 cubed. So we find out c is equal to negative 2 over 27. So to find our particular solution, we find our general solution and plug in our c. So y is equal to negative 2x cubed over 27.
For the next spot, we're going to be solving slope fields, which is basically an easier way to solve a differential equation graphically. So for that, we're going to use the equation y prime equals f of x comma y. And if you look at that, f will be the defined slope, and xy will be the coordinates you plug in. And that'll be in relation to another equation that you are given in the problems. So for example 3, we're going to be sketching a slope field. For this problem, it asks to sketch a slope field for the differential equation y prime equals x minus y for the points negative 1, 1, 0, 1, and 1, comma 1. So, in order to do this, the slope at any point xy is f of xy equals x minus y. So you're going to make this equation equal to the differential equation you're given. And basically all you have to do is plug in the coordinates into x minus y, the equation you're given, and you will find your slope for y prime. And when you have the coordinates you want, you will sketch this into a slope field. And in order to do that, you take the slope for each segment or plot points that you have used, and you will put it on a graph with small lines representing the slope at that given point. And that's basically all you have to do. And I believe there's one problem right here in this book. You have to sketch a solution using a slope field. And it says sketch a slope field for the differential equation y prime equals 2x plus y. And you want to use the slope field to sketch the solution that passes through the point 1, 1. So basically you want to find the equation that gives you 1, comma 1. So in order to do that, you're going to sketch your slope field by plugging in your x's and y's at different coordinates. So you can start at negative 2 and go all the way to 2 on the x, and negative 1 all the way to 1 on the y. and you'll plug that into this equation, and you'll find your slope at those given points, and you'll plot it on the graph. You'll analyze the graph and figure out which lines it follows in order to go past or pass through the point 1, 1. This is a really meticulous method, I warn you, but it is one way to solve for a differential equation.
Buckle my shoes.
Say something.
Knock at the
Hey,
door.
baby.
5, 6. Pick up
Ow,
the stick.
stop it.
Hey.
More,
Baby.
louder.
Hello. Can you hear me? Okay.
We're about to do general and
So,
practical
the next
equations.
section of this chapter is Euler's method.
How loud should it be?
Euler's method. Not yours. And so, Euler's method is a numerical approach to approximating the particular solution of the differential equation. Y prime equals f of x, y, which is also the slope that passes through the point x initial and y initial, which is the initial x and y.
Obvious. Okay. First example we got is y prime equals x minus y, passing through the point 0 and 1 using step of h equals 0.1.
Nice. Yes. And on these questions, they usually give you a graph. So this is the graph, and we drew the line. So since the steps are h equals 0.1, the initial, we already have the initial of the x, the y, the step, and the slope, which is x minus y.
It gives it to you right there.
Yeah. And so now we find x by using x prime equals x initial plus h.
No, it's x1. x1 equals
Oh man.
Easy,
x
right?
initial plus h.
Yeah.
Easy, right?
Then we find x1 by using
That's y1.
man.
Keep going. Keep going.
Okay. Then we find
y1 by using y1 equals y initial plus h of x and y initial parentheses.
Yep. So we found out all of these x's from using this equation right there, which is, x1 equals the initial plus the step. So if it's the second one, we want to put the step prior to it plus, or not the step prior to it, but the x value prior to it plus the h.
Yes.
So you're basically just adding h onto the next.
Yes.
So that one's pretty easy.
Cool.
Yep. And so the y's. Let's start with the y's. This is the initial plus the slope. Plus the step times the slope. So here it would be 1 is the initial y plus the step times the the slope, and then you plug in your initial right up there and there.
Oh, hold up. Right up where?
Here and here.
Okay.
So you plug those into your equation and figure all that out, and that's the answer there.
Nice.
0.9. And you do that for all of your y's.
It's really pretty.
I know. And then you put the information into an XY table. Good job.
What does that say in Chinese?
Oops, I just broke your pen.
What does that say in Chinese?
Hun hao. That's good job in Chinese.
Remember, guys, hun hao.
Yep.
Hey guys, let's play basketball.
I thought we were gonna go bowling.
They were fencing.
Ah.